All right, guys, good morning. So, I'll be solving some question for you now. The first one says, which of the following salt is not acidic? So, which of the following salt is not acidic? We have here sodium ethanoate, and then also ammonium chloride, also copper trichloride, and copper 2 tetrasulfate 6. So, this kind of question, you have to first check which parts are those, which parts makes up what kind of acid and what kind of base makes up those salts. So in the first instance now, the first one, sodium ethanoate. So the CH3COO part is formed from the weak acid ethanoic acid, and sodium is gotten from sodium hydroxide, so which is a strong base. So, and whenever you react a strong acid and a weak base together, you are going to get acidic salt. And whenever you react a weak acid and a strong base, you are going to get a basic salt. So because the reaction will not undergo complete neutralization, so the stronger one will have more influence on the product. So now, in this case now, the option A will be basic because sodium hydroxide is a strong base and ethanoic acid is a weak acid. So the product will be basic, because the ethanoic acid will not completely neutralize the sodium hydroxide. So option B, ammonium chloride, is formed from ammonia and hydrogen chloride. So hydrogen chloride is a strong acid, ammonia is a weak base. So the result will be what? Acidic, because you are reacting a weak base and a strong acid. Also, copper 3 chloride is formed from copper 2 chloride and chlorine. And in this kind of reaction now, copper 2 chloride itself is basic, is acidic, because it's formed from copper 2 hydroxide and HCl, which is a strong acid. So it's going to be acidic. So then option D now, copper 2 tetraxosulfate 6. Copper 2 tetrasulfate 6 is is the reaction between copper 2 hydroxide and hydrogen tetrasulfate 6. Tetrasulfate 6 acid is stronger than is a strong acid, while copper 2 hydroxide is a weak base. So the reaction will form an acidic salt. So the answer is option A, which is sodium ethanoate. So the answer is going to be option A. So now to the next question. On the periodic table, boron has lower ionization energy than beryllium. Why? So why does it have uh, lower ionization energy than beryllium? So you first of all, if you use the shell configuration method, you might think that is the normal way, because the normal way is that we think the higher the number of valence electron, the higher the ionization energy that is required, but not in all cases. Sometimes when the atom is not stable, so it will require lesser ionization energy than the one that is stable, especially when they are on the same period. So beryllium and boron now, they are in the same period. So the fact that boron has more electron in its outermost shell does not mean that it is now going to require higher ionization energy, because it is not stable. And you can see that when you use the orbital configuration method, you can see that on the p orbital is having space. So this still has the ability to move. Electrons still have the ability to move around those spaces. Making it unstable. Therefore, it is not balanced, or let's say it is not stable. So therefore, it will require lesser ionization energy. But in the case of beryllium, beryllium has 4 electrons, and it completely fills up those orbitals. There is no space at all. So that is more balanced. So that will require higher energy to to let those electrons, to let them go out of their orbital. So it require higher energy. So therefore, that is why the reason why boron requires higher ionization energy is because it is less stable than beryllium. So the next question says, which of these is amphiprotic? So for a compound to be amphiprotic, it means that to be amphoteric, that means it can lose hydrogen and also gain hydrogen. So it can lose proton or gain proton. So In this case now we have hydrogen chloride. Hydrogen chloride can lose its hydrogen but cannot gain, so it is not amphiprotic. So ammonia can gain to form ammonium but cannot lose, so that means it is not amphiprotic. So hydrogen fluoride can lose but cannot gain, so it is also amphiprotic. But in the case of this the last one, that is HCO3 2 minus, so it can actually gain hydrogen to form hydrogen triazocarbonate 4 acid, which is a weak acid, and also it can lose its hydrogen to form a carbonate with other compounds, uh, to just form a triazocarbonate. So that means the answer will be D. So the next question is, which of this is the weakest acid? Which of this is the weakest acid? So we have triazonitrate 5 acid. So triazonitrate 5 acid is always is a strong acid. It's one of the strongest acid. So that one is out of it. Then the next one is phosphoric acid. So we have H3PO4, that is hydrogen tetraoxophosphate 5. We have H2PO4 minus, that is tetraoxophosphate um phosphate 6, and then we have HPO42 minus. So phosphate acids are usually weak acids. So that is, you have to also have the knowledge of those elements and the kind of acid they form. So phosphoric acid are weak acid. And so and so um now, since we have three phosphoric uh acid, so which one, how do we determine the one that is the weakest? So, and the one that is able to give the least hydrogen out would be the weakest. So the one that is able to give the least hydrogen, for H3PO4 can give more hydrogen, so it is stronger than that. Then the next question is hydrobromic, identify the Bronsted base in the reaction between hydrobromic acid and hydroxide ion. And so according to Bronsted-Lowry theory, an acid is what can give a compound that can give out hydrogen or proton, and then a base is the one that can take in hydrogen. So as you can see now, according to from the reaction, that hydrobromic acid can give out hydrogen, so it is the acid in the reaction. And also hydroxyl ion can also take hydrogen to form water, so that's the base in the reaction. So now the conjugate acid is going to be on the product side. As according to the reaction, you can see water has the ability to lose one hydrogen, so and bromine has the ability to take in hydrogen. So bromide ion is the what conjugate base. So the shape of the hydrogen sulfide is what the shape of hydrogen sulfide. What's the shape of hydrogen sulfide? You can get the shape by either using the VSEPRT model, that is a valence shell electron pair repulsion theory, or you can also use the formula method. But let's go with the structure, the Lewis structure first method first. So as you can see now, sulfur has 6 valence electron. So when it combines with 2 hydrogen, it's going to have two lone pairs and 2 bond pairs. And the kind of geometry of a molecule that has this kind of 2 lone pairs and 2 bond pair is what, according to VSEPRT, is bent. So you can also use the formula method. How do you do that? You are going to look for the lone pair. Formula for calculating the lone pair is what is the surrounding the group, the central atom group number for sulfur, which is 6, minus the number of the combination power of the surrounding atom for hydrogen, which is 1. So as you can see now, I'm trying to calculate the lone pair here. So you can see the central atom group number is 6, minus the combination power of hydrogen is 1 times 2. So that is, you can see that's 4 divided by 2, because you are talking about lone pair here, so you are going to divide by 2, because pair means 2. So you can see now, using the steric number, you can see you have lone pair plus number of surrounding atom, so plus bond pair. So and the geometry of molecule with that is what is bent. So the next question is of the steric number of of a molecule having 2 lone pairs and 3 bond pair is what? So according to the formula of steric number, that is lone pair plus bond pair. So the answer is going to be 5. Lone pair plus bond pair. So this is just, so the next question says that which of the following is isoelectronic with neon? So isoelectronic means they have the same number of electron, and so neon has atomic number of 10. and um, then for let's see for oxygen 2 minus. You can see now that that 2 minus shows that it has gained 2 electron, and oxygen originally has atomic number of 8, so plus 2, that is going to be 10. So that means it also is isoelectronic with neon, because oxygen has atomic number of 8 and it gains 2 more electrons to have total of 10 electrons. All right, so the next question says that arrange this in the order of increasing energy. Arrange this in the order of increasing energy. So using the above principle, you can see I have 1s, 2s, 3s, 4s, 2p, 3p, 4p, 5p, 3d, 4d, and so like that. So you are going to, after you have written out the orbitals in order, so you can see, so the one that comes first has the lower energy level. So the higher you go, the higher the energy level. So from what you have written out, you can see that 4s comes before 3d, and then 3d comes before 4p. So that is how you go about that. So the next question says that which of the following pairs are isotones? So what are isotones? Isotones are elements that have the same number of neutrons. So you can see now hydrogen, and this is proton, and then deuterium. So when you subtract the mass number from the atomic number, you are going to see that for proton it has a zero neutron. Proton has zero neutron because the mass number minus the atomic number give you zero, and then also deuterium, the mass number minus the atomic number gives you 1. So therefore they are not isotonic. That means they don't have the same number of neutron. Also, for neon 22 and sodium 23, you can see that neon has atomic number of what, 10. So when you subtract 10 from 22, it gives you 12, and sodium has atomic number of 11. When you subtract it from 23, it gives you 12. So they both have the same number of neutron, that is isotonic. The next question is, when sodium hydrogen tricarbonate 4 is dissolved in water, the resulting solution is what? So sodium hydrogen tricarbonate 4, you have to first know if it is basic or acidic. So now the sodium there is gotten from sodium hydroxide, and the hydrogen tricarbonate 4, the HCO3 is gotten from hydrogen tricarbonate 4 acid. And so you can see now that sodium hydroxide is strong base, and H2CO3 is a weak acid. So therefore the resulting salt is going to be a basic salt. When you react it with water, when you dissolve it in water, it does not affect the basicity, it still be a basic salt. So what is true about this following equation? So you have hydrogen fluoride reacting with water to give what, hydrozonium ion and fluoride ion. And so now, according to Bronsted-Lewis theory, so the acid there is going to be the hydrogen fluoride because it has the ability to lose one hydrogen, and also the water there is the base because it has the ability to gain hydrogen from hydrogen fluoride, hydrofluoric acid, to form hydrozonium ion. And also that, so now the thing is, the correct answer will now be that hydrogen fluoride, hydrofluoric acid is the what, is the acid, while fluoride ion is the conjugate base, because that fluoride ion can gain hydrogen to form hydrogen fluoride back. So that's the conjugate base. Now another question is, what is the next question says that how many lone pairs are there in methane, and what is the steric number? So just like the method I used the other time, you can use the formula method. Lone pair, how do you calculate lone pair? Lone pair is the group number of the central atom and minus the combination power of the surrounding atoms. So now, as you can see, according to this question now, methane, carbon there is the central atom. So as you can see now, the lone pair here is 4 minus 4, that's 0 for methane. So the lone pair is 0. And then for the steric number is lone pair plus number of bond pairs, so that's 4. So so in that case the answer will be 0 and 4. 0 and 4. So for the next question, aluminium ion and sodium ion are what kind of pair of elements? So what kind of element are they? So what is common between them? So this is actually going to be most likely maybe like isoelectronic also. So you can see aluminium has atomic number of 13. When you subtract and the positive there means it has lost 3 electrons. When you subtract 3 from it, you have 10. And sodium as well, it has atomic number of 11. When you subtract 1 from it, it has 10. So that means they are isoelectronic. So the next question is, what does the principal quantum number represent? So when you refer back to your book, you see that it represents that the energy level of each shell, and the formula is 2n square, energy level of each shells. Also, next question says, for which of the following is difference between the neutron number and mass number positive? So which of the following? So now let's see, for the first one, hydrogen has the mass number of 2 and atomic number of 1. So the neutron is 1. Then tritium has mass number of 3 and atomic number of 1. The neutron is 2. And then the last one, which is protein, it has neutron of 0. So I guess in this question they're trying to ask the one that has the highest number of neutron. So that's what they're trying to ask in this case. All right, so the next question says that which quantum number determines the angular momentum of an electron? So when you refer back to your book again, so you see the quantum number, they have their various function, and so azimuthal quantum number is the one that actually used to that represent the angular momentum of each electron. So now the last question says that between 16 gram per mole gas and 64 gram per mole gas, which one effuses faster? And so according to the rate of effusion or diffusion, you see that it is inversely proportional to the square root of mass, molar mass. So that means as one increases, the other decreases. As the rate of effusion increases, the mass, the molar mass will decreases, and vice versa. So according to this question now, the one with the smaller molar mass is going to effuse faster. It's going to have a faster rate of diffusion than the one with the higher molar mass. So the answer will be 16 gram per mole. The next question says that which has the highest acidity in this: hydrofluoric acid, hydrogen sulfide, hydrogen selenide, and then hydrogen telluride. So which one has the highest acidity? So as you can see now, the higher the electronegativity, how do you know this? You are going to consider the element that bonds with the hydrogen. The one with the highest electronegativity will be the weakest one, and the one with the lowest electronegativity will be the highest one. So tellurium here has the lowest electronegativity because it is below selenide in the group. So it has lesser electronegativity down the group. It is the one that it has is below the group than selenide. So it's going to have, therefore it's going to form more acidic compound with hydrogen. So the answer will be hydrogen telluride. So because it has the least electronegativity and higher electropositivity in the periodic table. So alright, we have the next question, which is carbon 14, nitrogen 15, and oxygen 16. So what is common among them? They are what kind of compound of element? So for carbon 14, just subtract the atomic number from 14. You can see you have 888 when you subtract that. So that means they have the same number of neutrons, which makes them isotonic elements. Alright, so I see you in the next video. Thank you.